students. Today next unit, 10th unit, chapter number 10, straight lines. Straight lines. Take your book, page number 203. Page number 203, chapter number 10. Straight lines is a very simple chapter. Already studied last class, coordinate geometry. Last at grade 10, studying coordinate geometry. Distance between 2 points, plot the points on the plane and coordinate axis and etc. All already studied. Today same straight lines and slope of the lines. Slope of a line passes through 2 points. First of an introduction. And second is slope of line. And slope of line passes through 2 points. And parallel line, parallel and perpendicularity of lines. Of 2 lines. Straight line introduction. First one. Already you studied it in last class. Straight line. What is straight line? Straight line passes through 2 points. The straight line is passed through 2 points. This is a straight line. And 2 points P and Q. P and Q. We know distance between 2 points formula. Distance between 2 points P and Q. Let P and Q is x1, y1, x1, y1, and Q is x2, y2. Then the distance between the 2 points P and Q is, first of all, PQ. The distance between P to Q, that is PQ is root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Okay. Right. Second formula, internal bisection formula. That is a section formula. P is x1, y1, the same line. P is x1, y1 and Q is x2, y2. The line joining P to Q. Internal bisector of the points Q. Sorry, let all be the internal bisector of the line PQ. Right? PQ. The ratio is M is to N. The ratio is M is to N. Then the internal bisector of the line R is M is equal to, R is equal to M x2 plus N x1 by M plus N, comma M y2 plus N y1 by M plus N. This is a section formula, internal bisection or section formula. Already studied in the last class. And next is midpoint formula. Midpoint of the 2 lines. If M is equal to N, the ratio M is to N, internal bisector, this ratio is M is to N. This point is divided to the line PQ is M is to N ratio. Then the point R is equal to mx2 plus nx1 by M plus N, comma my2 plus ny1 by M plus N. Suppose M equal to N, the value M and N are equal. Substitute this equation. The midpoint of the line PQ is equal to M1 and N are equal. Then mx2 plus mx1 divided by 2n, comma my2 plus my1 divided by 2m. M will cancel the remaining x1 plus x2 by 2, comma y1 plus y2 by 2. This is a midpoint of this line P, comma Q. That is the midpoint of the line P Q is x1 plus x2 by 2, comma y1 plus y2 by 2. Right. Next, the area of the triangle. Area of triangle is passed through 3 points. Let us consider 3 points of A, B, C, D. A, B, C, sorry. A is x1, comma y1, and B is x2, comma y2, and C is x3, comma y3. Now the area of triangle. Area of triangle. So area of triangle ABC. Here the vertices A is x1, comma y1, and B is x2, comma y2, and C is x3, comma y3. The area of triangle ABC is 1 by 2 of modulus 1 by 2 of modulus x1 into y2 minus y3, x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. This is the area of the triangle ABC. When the vertices of the triangle A is x1, y1, and B is x2, y2, and C is x3, y3. This formula is already studied last class, chapter number 7, grade 10, coordinate geometry. Okay, right. Same formula, using these formulas, this chapter. Question number 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Right. Okay, listen. Take the slope of a line. Slope of a line. Listen. Draw the line L. This is a straight line. I consider as L. This line is L. Angle is theta. Angle is theta. Theta is an inclination, angle of inclination. Theta is angle made by the line with the x-axis, the positive direction. Positive direction. It is an anti-clockwise. Measure of anti-clockwise. Okay. Right. But theta is an angle of a line made with the line with the x-axis with the positive direction and measure of anti-clockwise. Theta is an inclination of the line. It is called inclination of a line. Okay, right. So theta range of theta is 0 less than or equal to theta is less than or equal to 180 degree. 0 less than or equal to theta is less than or equal to 180 degree. We know that the straight angle is 180 degree. You know that the straight angle is 180 degree. 180 degree. This line is 0 to 180 degree. 0 to 180 degree. This is an angle of inclination. Angle of inclination. If theta is equal to 0 degree, the line L is, which implies the line L is parallel to x-axis. If theta is equal to 0 degree, thus this line L is parallel to x-axis. Is it? This is L. This is x-axis. This line L is parallel to x-axis. Here angle of inclination theta is 0. Here angle of inclination theta is 0. So theta equal to 0 degree, then L is parallel to x-axis. And another one theta equal to 180 degree. Another one theta equal to 180 degree. Same, this line is parallel to x-axis. This line is parallel to x-axis. And theta is equal to 90 degree. If theta is equal to 90 degree, the line L is parallel to y-axis. parallel to y-axis. See here, this is x-axis, this is y-axis, the line L. This line L is parallel to y-axis, this line L is parallel to y-axis. The angle of inclination in the x-axis positive direction is 90 degree. Theta is 90 degree. Right. The slope of a line, right? Slope of a line L is tan theta. The slope of the line L is tan theta. Slope of the line L is m equal to tan theta. This is the slope of line formula. M equal to tan theta. Here theta is angle of inclination. This line with the x-axis. So m is slope of the line. So m is equal to tan theta. M equal to tan theta, and theta is 0 less than or equal to theta is less than or equal to 180 degree. 180 degree. Okay, right. Next, slope of line formula is m equal to tan theta. If theta equal to 0 degree, then the slope of line m is equal to tan 0 is 0. Tan 0 degree is 0. Theta equal to 0 degree. When the line is parallel to x-axis, then the slope of the line is equal to 0. Slope of the line m is equal to 0, and theta is equal to 90 degree. If theta equal to 90 degree, that is, this line is L is parallel to y-axis. Parallel to y-axis. That is perpendicular to x-axis. Another one, perpendicular to x-axis. So parallel to y-axis, that is for theta is angle of inclination. Theta is 90 degree. So theta equal to 90 degree. Then the slope of the line m is equal to tan 90 degree is infinite, that is not defined. It is not defined. If theta equal to 0, then the slope of the line is 0. And theta equal to 90 degree, the line is parallel to y-axis, then the slope of the line is equal to is not defined. It's not defined. Okay, right. Slope of non-vertical lines passing through the 2 points. The general formula, the slope of a line L is m equal to tan theta. Slope is called, another one name is gradient. Gradient of line or slope of line is called m equal to tan theta. Next, slope of a non-vertical line passing through the 2 points x1, y1 and x2, y2 is m is equal to y2 minus y1, y2 minus y1 by divided by x2 minus x1, divided by x2 minus x1. Right. Here x1 and x2 is not equal. x1 and x2 is not equal. Right. Let us consider x-axis and y-axis. X-axis, y-axis. I draw the line L. This is L and passes through the point P. Let the point P x, y1 is P, so x1, y1, and point Q is x2, y2. x2, y2. Here angle of inclination, the line L is theta. Theta is acute. Here theta is acute angle. Here theta is angle. A line is for the line perpendicular to x-axis, that is m. Another line is perpendicular to the line qm. This is r. This let us consider r. Here the angle QPR is theta. Angle QPR is theta. Here the angle of inclination, this line theta is angle of QPR is theta. Let us consider angle QPR is equal to theta. P is x1 comma y1 and Q is x2 comma y2. See here, the angle R is 90 degree. This line is perpendicular to x-axis and PR is perpendicular to QM. PR is perpendicular to QM. So the angle R is 90 degree. Therefore, triangle PQR. This triangle PQR is one of the right angle triangle. Is that right angle triangle? Okay, right. So this is right angle triangle by using the Pythagoras formula. And another one, ratios of trigonometric ratios. Tan theta, the slope of the line L is m equal to tan theta. We know that general formula m equal to tan theta. Then m equal to tan theta. Tan theta, you know that tan theta is equal to opposite side by adjacent side. Opposite side by adjacent side. Here opposite side is QR. Opposite side is QR. This is opposite side QR, and then adjacent side is PR. So QR divided by PR. QR divided by PR. QR is distance between the point Q and R. Distance between the point Q and R. You know that the point P is x1 comma y1. So the horizontal length O to L is x1. This is x1, and O to M. This is x2. Okay, right. And vertical length CP is y1, and vertical length MQ is y2. MQ is y2. Then the distance between QR is called QMQ minus PC. That is MQ minus RM. Therefore, the QR is equal to y2 minus y1. Y2 minus y1. We need QR length. Here, QM is equal to y2. QM is equal to y2. Then QR is equal to y2 minus this value. This value is y1. So y2 minus y1. Divided by PR. PR is distance between the point P and R. P and R. Here P is x1 comma y1. Another point is R. This is PR. We have made the answer PR. So we know that OM is equal to x2. OM is equal to x2 and OC is equal to x1. OC is equal to x1. PR and also is equal to CM. So we need CM is equal to OM minus OC. OM minus OC. That is x2 minus x1. That is x2 minus x1. So the distance between P to R is called x2 minus x1. x2 minus x1. So therefore, the slope of the line M is equal to y2 minus y1 divided by x2 minus x1. This is the equation number 1. When theta is acute angle, here theta is acute angle. Here theta is acute. This is case 1. This is case 1. And another one case 2. Case 2. Case 1 theta is acute, and case 2 theta is when theta is obtuse. Theta is obtuse. Draw the line L when theta is obtuse. Here theta is obtuse side. Passes through the point P and Q. P is x1 comma y1 and Q is x2 comma y2. Q is x2 comma y2. Draw the perpendicular line from Q to x-axis. This is called M. And another one perpendicular line from P to QM. P to QM. This is L as R. This is R. Right. Say P is x1 comma y1 and Q is x2 comma y2. This line L is passes through P and Q. Here angle of inclination theta is obtuse. Theta is obtuse angle. Here theta is equal to, here theta is equal to, this is theta, 180 minus theta. 180 minus theta. We know that the straight angle, straight line, straight angle is 180 degree. 180 degree. Here the angle is, this point is called B. The angle B is called theta. Then another one, angle MBL is 180 minus theta. That is angle RPQ. Angle RPQ. Angle RPQ is equal to 180 degree minus theta. This is called 180 degree minus theta. Okay, right. Then theta is equal to 180 degree minus angle RPQ. Angle RPQ. So theta is equal to 180 degree minus angle RPQ. You know, a slope of line M is equal to tan theta. M equal to tan theta. Then theta is here 180 degree minus angle RPQ. That is tan of theta 180 degree minus angle RPQ. This is tan of 180 minus theta form. So the tan of 180 minus theta is equal to minus tan of angle RPQ. Angle RPQ. So the line M is equal to minus tan angle RPQ. Minus tan angle RPQ. See this diagram. The angle RPQ is 180 minus theta. And we have made minus tan of RPQ. This is a triangle. QRP is a right angle triangle. Then tan of angle RPQ is equal to minus opposite here. Opposite side is QR and adjacent side is PR. So QR divided by PR. QR divided by PR. Okay, right. Here PR, the horizontal distance length is here. The horizontal distance O to P. This is O to P or L. Sorry. OA is called X1, Y is called X1, and OM is called X2. OM is called X2. We have the distance P to R. P to R. Then the P to R is equal to X1 minus X2. P to R is equal to x1 minus x2. So divided by PR is x1 minus x2. x1 minus x2. Another one, the distance between Q to R. Distance between Q to R. Here the Q, the point Q is x2 comma y2 and R. Q, this is the required value. We know the value O to Q. The O to Q is y2. O to Q is y2 and O to R is y1. This value is y1 and whole value is y2. We need rq. So y2 minus y1. y2 minus y1. So qr is equal to y2 minus y1. y2 minus y1. So the slope of the line m is equal to minus of y2 minus y1 divided by x1 minus x2. Is written as y2 minus y1 divided by minus of x1 minus x2 is x2 minus x1. So m is equal to y2 minus y1 divided by x2 minus x1. This is equation number 2. This is equation number 2. When theta is acute angle, case 1, from the equation number 1, the slope of the line is y2 minus y1 divided by x2 minus x1. And also say when theta is obtuse angle, the slope of the line L is m equal to y2 minus y1 divided by x2 minus x1. So from 1 and 2 same, both are same. Therefore, the slope of the line L is y2 minus y1 by x2 minus x1. When the line is passes to the point x1 comma y1 and x2 comma y2. The slope of the line is y2 minus y1 by x2 minus x1, or y1 minus y2 divided by x1 minus x2. But x1 and x2 are not equal. Okay, right. Then the condition for parallel lines and perpendicular lines. Condition for parallelism and perpendicularity of given two lines. Let us consider L1 and L2 are two lines. Two lines are parallel. If two lines are parallel, if and only if their slopes are equal. If and only if their slopes are equal. That is M1 equal to M2. M1 is called slope of first line and M2 is called slope of second line. Then two lines are parallel. Then if and only if their slopes are equal. That is M1 equal to M2. This is the first one point. And second one point, if two lines are perpendicular. If two lines are perpendicular, if and only if the product of their slopes is minus 1. Product of their slope is minus 1. That is M1 into M2 is equal to minus 1. M1 is called slope of the first line and M2 is called slope of second line. Slope of second line. Right, is it? First one. Let us consider L1 and L2 or two lines. Or two lines. Draw the two lines. Two parallel lines. This is L1 and another one this is L2. So L1 angle is alpha and L2 angle is angle of inclination is beta. Here L1 and L1 and L2 are parallel. L1 is parallel to L2. These two lines are non-vertical line. These two lines are parallel to each other. L1 is parallel to L2. L2 is parallel to L1. So L1 is parallel to L2. Then their angle of inclination alpha and beta are equal. Then the angle of inclination. There is angle. There is inclination. When the inclination are equal. That is alpha equal to beta. That is alpha equal to beta. If two lines are parallel, then the inclinations are equal. So alpha equal to beta. If alpha equal to beta, then tan alpha is also equal to tan beta. Alpha equal to beta, and tan alpha is also equal to tan beta. Tan alpha is called slope of the line L1. Slope of the line L1. That is called M1. And tan beta is slope of the line L2. That is called M2. So M1 is equal to M2. M1 is equal to M2. So given two lines are parallel, then the angle of inclination, the inclination of angle is equal. So alpha equal to beta. Alpha equal to beta if only if tan alpha is also equal to tan beta. Tan alpha is here called slope of the first line L1. That is M1. That is not M1. And tan beta is called slope of the line L2, so M2. So M1 equal to M2, the first point. And second one point, if two lines are perpendicular, let us consider L1 and L2 are two lines. Parallel two lines, x-axis and y-axis. Two lines are perpendicular. This is L1 and this is L2. These two lines are perpendicular. So angle of the inclination of the line L1 with the x-axis is alpha. And inclination of L2 is beta. Okay? Right. Here alpha is inclination of the first line. So the slope of the line L1 is M1 is equal to tan alpha. M1 is equal to tan alpha. and slope of the second line, L2 is M2 is equal to, here inclination is beta, so tan beta. Okay, right. Here alpha is acute and beta is obtuse. Beta is an obtuse. Consider this one point is P, this is Q, this is R. This point is R. The PQR is a triangle. PQR is a triangle. There is right angle triangle. This is right angle. So this is right angle triangle. From the diagram, the triangle PQR is right angle triangle. This triangle is called right angle triangle. One angle R is right angle, so this is right angle triangle. Alpha, angle P is alpha and angle R is 90 degree. And angle Q is, this is 180 minus beta. 180 minus beta. You know that the sum of interior angle of a triangle is equal to 180 degree. That is angle P plus angle Q plus angle R is equal to 180 degree. Already you know, last class studied this theorem. So angle P plus angle Q plus angle R is equal to 180 degree. Right. Here angle P is alpha, angle Q is 180 minus beta. 180 minus beta. The angle R is 90 degree. Is equal to 180 degree. Is equal to 180 degree. Right. So alpha minus beta. Alpha minus beta is equal to, alpha minus beta plus 90 degree is equal to 180 cancel. 180 cancel, remaining 0. So alpha minus beta plus 90 degree equal to 0. Then beta is equal to 90 degree plus alpha. Beta is equal to 90 degree plus alpha. Right. You know that slope of the line L2 is M2 is equal to tan beta. So M2 is equal to tan beta. Beta is 90 degree plus alpha. Beta is 90 degree plus alpha. You know the formula, tan of 90 plus theta is equal to minus cot theta. Here tan of 90 degree plus alpha is equal to minus cot alpha. Minus cot alpha. The minus cot alpha is written as reciprocal of tan alpha. That is minus 1 by tan alpha. Minus 1 by tan alpha. Already M1 is tan alpha. M1 is equal to tan alpha. Here minus 1 by tan alpha is written as minus 1 divided by M1. So therefore M2 is equal to minus 1 divided by M1. Minus 1 divided by M1. Or M1 is equal to minus 1 divided by M2. Or M1 into M2 is equal to minus 1. M1 into M2 is equal to minus 1. So therefore, if two lines are perpendicular, these two lines L1 and L2 are perpendicular to each other, if and only if the product of dash slopes M1 into M2 is equal to minus 1. M1 into M2 is equal to minus 1. Another one, two non-metric lines are perpendicular to each other if and only if the slopes are negative reciprocal of each other. This is negative reciprocal of each other. If two non-metric lines are perpendicular to each other, the slopes are negative reciprocal of each other. That is M2 equal to minus 1 by M1 or M1 equal to minus 1 by M. Okay, these 2 points are very important. So two lines are parallel, then the slope of the lines are equal. So M1 equal to M2. Two lines are perpendicular if and only if the slopes of the product is minus 1. That is M1 into M2 is equal to minus 1. Okay, right. Right. Once again, I recall the formula. First of all, distance between 2 points x1 comma y1 and x2 comma y2 is equal to root of x2 minus x2 whole square plus y2 minus y1 whole square. And the section formula, integral division section formula, ratio is m is to n is mx2 plus nx1 divided by m plus n, comma my2 plus ny1 divided by m plus n. If m equal to n, the integral division point is midpoint of the line. So midpoint of the line PQ, that is P is x1 comma y1 and Q is x2 comma y2. And the midpoint formula is x1 plus x2 by 2 comma y1 plus y2 by 2. And another one, the area of triangle formula. When the vertices of the triangle is A is x1 comma y1 and B is x2 comma y2 and C is x3 comma y3 is 1 by 2 of modulus x1 of y2 minus y3 plus x2 of y3 minus y1 plus x3 of y1 minus y2. Right. Next one, slope of the line. Inclination of a line is theta and slope of the line m is equal to tan theta, and slope of the line when the line is passes through the 2 points x1 comma y1 and x2 comma y2 is m is equal to y2 minus y1 divided by x2 minus x1 or y1 minus y2 divided by x1 minus x2. And another one, two important point. If two lines are parallel, then their slopes are equal. Then their slopes are equal only if their slopes are equal. If two lines are perpendicular, if and only if the product of the slope is equal to minus 1. Product of the slope is equal to minus 1. Right. Next, exercise number 10.1. Exercise number 10.1, page number 211. Page number 211. Very simple sum. Question number 1. Question number 1. Draw a quadrilateral in the Cartesian plane. Draw a quadrilateral in the Cartesian plane whose vertices are minus 4, 5. Whose vertices are minus 4, 5, 0, 7. 5 comma minus 5 and minus 4 comma minus 2. Minus 4 comma minus 2. Find its area. We need the area of quadrilateral. We need the area of quadrilateral. Let us consider the vertices of the quadrilateral. Minus 4 comma A is called A and 0 comma 7 is called B and 5 comma minus 5 is called C and minus 4 comma minus 2 is called D. Draw the quadrilateral. So x-axis, y-axis, this is x-axis, this is y-axis. What's the origin? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 1, minus 2, 4, minus 5. Right. Plot these points. First one point, A is minus 4 comma 5. Minus 4 comma 5. Here minus 1 is left hand side and 4 is above the x-axis. This is minus 4 comma 5. This is called minus 4 comma 5. This is A. This point is not A. And 0 comma 7. 0 comma 7. This is 0 and y coordinate is 7. So this is 0 comma 7. 0 comma 7. This point is 0 comma 7. And third point, 5 comma minus 5. So x value is plus 5 and y value is minus 5. So below the y-axis, this is 5 comma minus 5. This is called C. This point is called C. And last one point, minus 4 comma minus 2. Minus 1 left of y-axis and minus 2 below the x-axis. Third quadrant, this is minus 4 comma minus 2. This point is called D. So join A, B, C, D. Join A, B, C, C, D and D. This is a quadrilateral A, B, C, D. This is quadrilateral A, B, C, D. Let us consider the AC is a diagonal of a quadrilateral A, B, C, D. So A, B, C, D is a quadrilateral. AC is is let us AC as diagonal of a quadrant. Diagonal of ABC. We need the area of quadrilateral ABC. We need area of quadrilateral ABC. The area of quadrilateral ABCD, area of quadrilateral ABCD is equal to, this quadrilateral is divided into triangle. That is ABC is one triangle is ABC. This is ABC, and another one triangle is ACD. So the area of quadrilateral ABC is equal to the area of quadrilateral area of triangle ABC plus area of triangle ACD. Area of triangle ACD. We know that the area of triangle formula. The triangle area formula is 1 by 2 of modulus of x1 into y2 minus y1 plus x2 into y3 minus y2 minus y3, x2 into y3 minus y1 plus x3 into y1 minus y2 minus, this is the area of triangle formula. This is x1 comma y1 and x2 comma y2 and x3 comma y2. Right. Find the area of ABC. Find the area of triangle ABC. Area of triangle ABC is equal to, here A is minus 4 comma 5 and B is 0 comma 7 and C is equal to 5 comma minus 5. 5 comma minus 5. So minus 4 comma 5 is x1 comma y1 and 0 comma 7 is x2 comma y2 and 5 comma minus 5 is called x3 comma y3. Substitute this formula. So the area of triangle ABC is 1 by 2 of, here x1 is minus 4 into, and y2 is 7, minus y3 is minus 5, so minus of minus 5 is plus 5, minus of minus 5 is plus 5, plus x2 value is 0, x2 value is 0, 0 anything 0, so like next x3 value is here 5, x3 is 5 into y1 is minus 4, y1 is minus 4 and y2 is 0, so y1 is 5 and y2 is 7, 5 minus 7, okay, right, simplify this, so 1 by 2 of minus 4 into 7 plus 5, 7 plus 5 is 12, so 12 into minus 4 is minus 48 plus 5 into 5 minus 7 is 4 minus 2, so minus 2 into 5 is minus 10, is equal to 1 by 2 of minus 48 minus 10, modulus of minus 48 minus 10, so minus 48 minus 10 is called minus 58, so modulus of minus 58 is plus 58, modulus of minus 58 is plus 58, so plus 58 divided by 2 is equal to 29 square units, 29 square units. So the area of triangle ABC is 29 square units. This area is 29. This area value is 29. Right. Next, the area of triangle ACD is fine. The area of triangle, one of the triangle ACD. A is minus 4 comma 5 and C is 5 comma minus 5 and D is minus 4 comma minus 2. Minus 4 comma minus 2. Here A is minus 4 comma 5 is x1 y1 and 5 comma minus 5 is x2 y2 and minus 4 comma minus 5 is x3 y3. Right. Find the area of triangle ACD. Triangle ACD is equal to, the formula is 1 by 2 of modulus x1. Here x1 is minus 4, So minus 4 of y2 minus y3. Here y2 is minus 5. So minus 5 minus y3 is minus 2. So minus of minus 2 is plus 2. Plus x2 is 5. x2 is what? 5 into y3. Here y3 is minus 2. Minus y1 is 5. So minus 2 minus 5. Plus x3 is minus 4. x3 is minus 4. And y1 minus y2. Here y1 is 5 and y2 is minus 5. So minus 5 of minus of plus 5. Simplify this value. So 1 by 2 modulus of minus 4 into minus 5 plus 2 is minus 3 plus 5 into minus 2 minus 5 is minus 7 minus 4 into 5 plus 5 is 10 is equal to 1 by 2 of 1 by 2 of minus 4 into minus 3. 4 is 12. 12. 5 into minus 7. 5 into minus 7 is minus 35. Minus 35. 4 into 10 is minus 40. Minus 40. So simplify this value is equal to 1 by 2 of 1 by 2 of 12 minus 35 minus 40. 5 minus 40 minus 35 is minus 75. Minus 75 minus 12. So plus 12. Minus 75 plus 12 is 63. Minus 63. Minus 63 is called modulus of minus 63 is plus 60. So 63 by 2. 63 by 2. Therefore, the area of triangle ACD is 63 by 2. ACD is 63 by 2. So the required answer is area of ABCD. Area of quadrilateral ABC. So the area of quadrilateral ABC is area of triangle ABC plus area of triangle ACD is equal to area of triangle ABC is 29 plus the area of triangle ACD is 63 divided by 2. 63 divided by 2. Simplify this. 29 plus 63 divided by 2 is equal to 58 plus 63 divided by 2 is equal to 121 divided by 2. Therefore, the area of quadrilateral ABCD is equal to 121 divided by 2 square unit. 121 divided by 2 is square unit. Okay? Right. Next question number 2. Question number 2. The base of a quadrilateral. The base of an equilateral triangle. Base of an equilateral triangle with the side 2A lies along the y-axis such that midpoint of the base is at the origin. Midpoint of the base is at the origin. Find matrices of a triangle. So base of an equilateral triangle with side 2A lies along y-axis. So draw the diagram. This is x, this is y. Equilateral triangle with side is 2A. Side is 2A. This is 2A. This is A. This is B. This is C. A, B, C. This is a triangle A, B, C or A, B dash, C dash. B dash, C dash. So base is AC. AC is called A plus A, 2A. This is AC is equal to 2A. Equilateral triangle. This base 2A is lies on y-axis. It is on y-axis. Right. As such that midpoint of the base is at the origin. This midpoint of the base AC is equal to at origin O was the midpoint of base AC. Right. Then find vertices of triangle. Find vertices of this triangle. That is of A, B, C or A, B dash C. Okay? Right. And given information, given triangle, let us consider a triangle ABC. Given triangle is equilateral. equilateral triangle. So equilateral triangle means the sides are equal. Sides of a triangle are equal, which implies AB equal to BC equal to CA. Here already another information, and base of the triangle AC is 2A. A plus A, 2A. So AB equal BC equal CA is equal to 2A. AB equal to BC equal to CA equal to 2A. This base is 2A. And second one information, and the base, the midpoint of the base was the midpoint of AC, the base AC. So therefore OC is equal to OA is equal to A. Therefore OC equal to OA is equal to A. Therefore the vertices of A is called, A is on y-axis, so A comma 0. The vertices of triangle A is lie on y-axis. Here the x value is 0, so sorry, 0 comma A, and C is lying on y-axis, so C is 0 comma minus A, and the other one find B and B dash. We need the point, the vertices B and B dash. Right? Let us consider from the diagram AOB, triangle AOB, right angle triangle AOB. This right angle, this is a right angle triangle, so this is a right angle, so AOB is a right angle triangle. Okay, right here AB squared is equal to, by the Pythagoras formula, AB squared is equal to OB squared plus OA squared. OB squared plus OA squared. AB is a side of triangle. AB is equal to 2A. So AB squared is 2A the whole square equal to OB. OB is unknown, so OB squared plus OA answer. Here OA is equal to A from equation number 2. OA equal to A. So substitute this value to A squared, which implies OB squared is equal to 2A the whole square minus A squared. That is 4A squared minus A squared is equal to 3A squared. So OB squared is equal to 3A squared. Then OB is equal to plus or minus root 3A. OB is called plus or minus root 3A. OB is plus root 3A, and similarly, and OB dash is equal to minus root 3A. OB dash, here OB is root 3A and OB dash is minus root 3A. So left of x, so minus. So distance is plus root 3A. So left of x is called minus root 3A. So therefore, now vertices of triangle B is called plus or minus root 3A comma 0. Plus or minus root 3A comma 0. Therefore, the vertices of a given triangle, the vertices of a given triangle is 0 comma A, 0 comma minus A, and plus or minus plus root 3A comma 0 or minus root 3A comma 0. Therefore, the required vertices are 0 comma A, this is 0 comma A, 0 comma A, and 0 comma minus A, this is 0 comma minus A, and B is plus root 3A comma 0, and B dash is minus root 3A comma 0. So required vertices 1 0 comma A, 0 comma minus A, root 3A comma 0, or 0 comma A, 0 comma minus A, minus root 3A comma 0. Yes. Okay, right. Next, remaining questions. Time. Okay, right. Remaining question 3, 4, 5, 3 to 14. Okay, it's in next class. Bye.